So now we're going to talk about really just the chain rule backwards. So what if we want to integrate a composite function? So let's look at what's going on in here. If we want to integrate f of g of x, you have to have g prime of x dx to do that. And when you do, you integrate that outside function, and you're going to get that antiderivative capital F of g of x. And we're always going to have the plus c because this is an indefinite integral, which means we do not have any limits of integration or no numbers here and here on that integrand side. So usually what happens here is we do a u substitution. We let u be that inside function. So then du is the derivative of that inside function. And remember, we have to show we took that derivative with respect to x. So that's where that dx is coming from. So then when we do our substitution, we're integrating f of u with respect to u. So we're going to get that antiderivative of u, which is what that capital F means, plus some constant of integration. So then we can see we're thinking about this is a composite function. So outside function, inside function here, and then the derivative of that function. So if we were to work backwards, let's say we wanted to take the derivative with respect to x of that composite function. Then when you take the derivative of the antiderivative, you get that lowercase f of x. So that's the derivative of your outside, and then you have to take the derivative of the inside. This is your chain rule. And then we're going to have that. Notice that that's what we would have started with in here. So then your general power rule, all it says is you're going to add 1 to the exponent, divide by the new exponent. Notice this is your chain rule also. There's your inside function. You have to have the derivative of the inside function. So then we could do that u substitution just like we did above. So let's take all this theory and let's put it into practice. Let's do a few. So in number 10, we are integrating x squared minus 9 to the third times 2x dx. You really have to think about what your u is. So we're going to let u be that inside function. It's the same thing that we did before. So du is the derivative of the inside. So we have 2x, and we need to show what we took the derivative with respect to. So that's why we're going to use a dx here. So we took that derivative with respect to x. So if we do our substitution, we are now integrating u cubed times du. Notice that 2x dx is all part of du, so we make that substitution there. So it gets absorbed in a way as part of your du. So then we're going to integrate. We're going to have u to the fourth over 4 plus c. And then if we sub back in, and I'm going to write it this way, 1/4 times our u to the fourth plus c. So there's our final answer. Okay, this one was nice because it had that du with it. It doesn't always happen, but we'll talk about what happens. Let's do another one. Let's look at number 12. So number 12, we are integrating the cube root of 3 minus 4x squared times negative 8x dx. So we're going to do a u substitution again. We're going to let u be that inside function. So du is the derivative of the inside. So that would be negative 8x times dx. And we need that because we need to show what we took the derivative with respect to. So that negative 8x dx, all of that is part of our du. So then when we do our substitution, we are integrating the cube root of u with respect to u. But remember, we need to rewrite that as u to the 1/3 times du. You have to have something here so you know what you're integrating with respect to. So it's got to be a dx, a du, a d something. So when we integrate, we're going to get u to the 4/3 divided by 4/3 plus c. And that's really 3/4 u to the 4/3 plus c. So then when we do our substitution, we're going to get 3/4 times that u to the 4/3 plus c. So there's our final answer. If we were to take the derivative of this, we will get this guy back. Just for fun, let's check this one. So we want to take the derivative of what's in there. So that guy. Remember, this notation means you want to take the derivative of what follows. So if we take the derivative, we're going to keep that number in front. We're going to bring the exponent down. We're going to subtract 1 from the exponent. And we're going to take the derivative of the inside. And the derivative of c is a 0 since that's a constant. So if we simplify this, we're going to get 3 minus 4x squared to the 1/3 times the negative 8x. So you can see that's the same thing we started with if we scoot back up in here. So like we said before, that negative 8, that du, all of this gets absorbed into that du, and that's always going to happen. Let's do another one. Let's look at number 14. So I'm going to rewrite this just a little bit. So let's think about what our u is. U is going to be that inside function, 6 minus x cubed. So du is negative 3x squared. You always get to pick u. Du results from what you pick for u. Now, if we look at this, we have the x squared. Notice we're missing the negative 3. So we can be really clever here. We could multiply everything by a negative 3 as long as we compensate with a negative 1/3 somewhere else in the problem. So what we're really doing, if we multiply those red terms together, we're really multiplying this thing by 1, and we know if we multiply anything by 1, it doesn't really change the problem. So it's just a clever way of multiplying by 1. We can always multiply numbers in, multiply by 1. However, if we were missing the x squared, this would now be something we cannot integrate. You can't multiply variables in just because it changes domains and does really weird stuff. You cannot multiply variables in, but you can multiply numbers in. So that's a nice trick to have in our bag of tricks. So now we have that negative 3x squared. dx because we took that derivative with respect to x. So we're going to do our substitution. So we have that negative 1/3 on the outside. And this becomes u to the 5th times du. So we have negative 1/3 times u to the 6th over 6 plus c, which is negative u to the 6th over 18 plus c. Or we could write that as negative 1/18 u to the 6th plus c. So then if we sub back in, this was the integration step. So if we sub back in, we're going to have negative 1 over 18. Our u is 6 minus x cubed to the 5th plus c. Let's look at 16. And we're going to do a rewrite on that one too. So we have 5x squared plus 4 cubed. And I'm going to put the x dx out here. So think about what you would let u be. And you may want to pause the video and try a few of these on your own and then check your answers. U is going to be that inside, 5x squared plus 4. Du is a derivative of that, which is 10x. And we need to show what we took the derivative with respect to. So we took the derivative with respect to x, so we got to put that dx there. Now, if we look, we have the x dx, but we're missing that 10. So we can multiply by 10 here as long as we compensate with a 1 over 10 somewhere else. That way we're really multiplying by 1 here. So then we're going to do our rewrite. So we have 1 over 10 times the integral of u cubed du. All of that 10x dx is du. So then integrate. We have 1 over 10 u to the 4th over 4 plus c. And that's 1 over 40 u to the 4th plus c. And then if we sub back in, our u was 5x squared plus 4. So there's our final answer. Let's do another one. Let's look at 18. So these are all going to work the same way. I'm going to rewrite this. That square root's the same thing as a 1/2 power. So we have 2t to the 4th plus 3 to the 1/2. And we're going to have that t cubed dt out here. So now we're integrating with respect to t. U is the inside function. So du is 8t cubed dt. What are we missing here? In this case, we are missing the 8. We can put it in as long as we multiply by 1/8. Compensate for what you put in. And I like to do that on the outside. That way it's already in the right place. So we can do a rewrite. So this is 1/8 integral of u to the 1/2 du. All of that 8t cubed dt is du. Integrate. This is going to be u to the 3/2. And then we would divide by 3/2, which is the same thing as multiplying by 2/3. Plus c. So if we reduce here, that 2 and 8 reduces, so we're going to end up with a 1/12 there. So then if we rewrite this, well, let's do our substitution. I'll call it sub. So we have 1 over 12, 2t plus 4, 2t to the 4th plus 4, to the 3 halves, plus c. So keep in mind, any of these, we can take the derivative, and as long as we took the derivative and we got back to what we started with, we would have the right answer. So it's a good way to double check your answers. Let's do another one. Let's look at 24. So we're going to rewrite this. We're going to bring that 4x cubed minus 9 to the negative, to that third up. So that's going to become a negative 3 exponent. And then we have a 6x squared dx. So u is going to be the inside function. So we have 4x cubed minus 9. Du is the derivative. So we need a 12x. So let's look at what we have. We have a 6x squared. But we need a 12. So for us, the easiest thing to do would be to multiply by 2. Then we would have a 12. But because we multiplied by 2 here, we need to compensate with a 1/2. So we're going to do our rewrite. So we have 1/2 times the integral of u to the negative 3 du. All of that's becoming du. We can integrate. Remember, we're going to add 1 to the exponent and then divide by the new exponent. So that's going to give us a negative 1 over 4u squared plus c. And then if we sub back in, we have negative 1 over 4 times 4x cubed minus 9 squared plus c. So there's our final answer. Let's look at 26. Twenty-six is going to work the same way. So this is 1 plus x to the 4th to the negative 1/2. So we rewrite that square root as a 1/2, and then if we bring it up, the exponent becomes negative times x cubed dx. So u is the inside function. Du is 4x cubed dx. We are missing the 4. We can multiply it in as long as we compensate with a 1/4. So in our rewrite, we have 1/4 times the integral of u to the negative 1/2 du. All of that piece is now du. So it gets absorbed. The x cubed gets absorbed as du. If we integrate, we have 1/4 u to the positive 1/2. If we divide by 1/2, that's the same thing as multiplying by 2 over 1 plus c. And that becomes a 1/2 u to the 1/2 plus c. So then if we sub back in, we have 1/2 times the square root of 1 plus x to the 4th plus c. So let's look at some trig one. These are going to be fun. So in 41, we are integrating the cosine of 6x dx. There is an understood parentheses around that 6x. So u is the inside function, which is that angle 6x. du is the derivative, so it's going to be 6. And we need to show we took the derivative with respect to x. So we are missing the 6 from du. Now if we multiply the 6 in, we have our du, but we need to compensate with the 1/6. So then we're going to do our substitution. We have 1/6 integral cosine of u du. When we integrate cosine, we get sine. So then if we sub back in, there's our final answer. And let's do 45. So in 45, we are integrating sine of 2x cosine of 2x dx. There's a couple of ways to think about this. Here's the one I see. I could let u be sine of 2x. So then du, the derivative of the sine is cosine. And then we have to take the derivative of the angle, which would be a 2 dx. So you can see what's going on in this problem. If the sine of 2x is u, then all of this becomes du. However, we're missing the 2. We can multiply it in as long as we compensate with a 1/2. So now if we rewrite this, we're going to be integrating 1/2 integral of u du. Because remember, we called this guy u, and everything else became du. So if we integrate, this becomes u squared over 2 plus c. And that's 1/4 u squared plus c. So then if we sub back in, we have 1/4 sine of 2x, and that's quantity squared plus c. And we're used to seeing a sine squared written this way. So there's our final answer.